Welcome back, everybody. Ready to dive into some fascinating stuff?
Always.
Okay, great. Today, we're going deep on something that affects us all every single day, even if you've never written a line of code in your life.
That's right. Those little glitches, the hiccups in our apps.
Exactly. Defect management, or as many of us would call them, bugs. You sent us a ton of material on this, most of it focused on a guide from Guru 99. So our mission today is to understand how those bugs are hunted down, categorized, and then hopefully squashed for good.
And it's not just for techies.
Nope.
Understanding this process can give you, the listener, a whole new appreciation for what goes on behind the scenes of the apps and websites we use constantly.
Seriously. So Guru 99 breaks this down into 6 key steps,
How do you
right?
do?
And step 1 is discovery. Imagine, just picture this, a new version of, say, your favorite social media app, it's about to launch.
Big day.
Huge, but before it hits the App Store, there's a whole team of testers, like digital detectives, on the hunt for any issue that could derail the whole thing.
And it's not just them working alone.
Oh, right.
We've got 2 ways these defects are found. Some, are through the testing team's own process, but others are reported by stakeholders.
So that could be like internal teams, beta testers, even early users, right?
Exactly. Anyone with a vested interest in this software working smoothly.
Okay, so you've got these 2 streams of potential bugs coming in, but, and let's be honest here, what one person calls a bug, someone else might say, hey, that's a feature.
It happens all the time.
So how do you even begin to sort through that mess?
Structure, my friend. It's all about clear communication and a structured approach. Because it is common, for a tester to flag something and the development team's like, nope, that's how we designed it.
Can you give us an example of that, something relatable?
Sure, think about button placement. A tester might say, this button's in an awkward spot, users are going to be confused, but the developers are like, no, that's intentional. It's part of our new minimalist design philosophy.
Ooh, I see how that could get, well, a little heated.
Especially with deadlines looming. And that is precisely when the test manager steps in.
They're like the referee.
Exactly. Neutral party, using predefined criteria to decide if something is truly a defect or just a difference of opinion. Remember that time, not going to name names, but a very popular social media app kept crashing.
Oh yeah, everyone was freaking out.
That, my friend, was likely a defect that slipped through the cracks. A strong test manager with a solid process, they can help prevent that chaos.
Okay, so they're the ones making sure everyone plays fair in this digital game of bug squashing.
That's a great way to put it.
And once a defect is found, we move on to step 2.
Which is,
Categorization. Guru 99 makes it clear, not all bugs are created equal, right?
right, just like in a hospital, some issues are, get them to surgery now, and others can wait a bit.
So how do we sort these digital ailments?
By severity.
Yeah.
Categorizing bugs based on how severe they are, that's how we prioritize resources, who works on what, and how fast.
Makes sense. Guru 99 gives us 4 main categories. Can we walk through them using that social media app example again?
Absolutely. So, critical, that's a showstopper. Imagine, users can't log in.
Oh, no.
Total shutdown, the app's unusable.
Yeah.
That is critical.
Yeah.
It needs immediate attention because we're talking millions of users locked out. Potential PR disaster.
Yeah. Companies definitely don't want that.
No way. Okay, next level down. High severity. Still impacts key features, but the app might sort of kind of work.
Give me an example for that one.
Let's say you can log in, you can scroll through your feed, but direct messaging is totally busted.
Oh, so annoying.
Right, it'll frustrate users, but it's not a complete meltdown.
Okay, then what's next? Medium. Is that like visual glitches?
Exactly. A button's slightly off, the color scheme's weird in one section.
But it still basically functions?
Yep. It's not ideal, but users can still, for the most part, do what they need to do.
Like, a crooked picture frame. You'll fix it eventually, but it's not an emergency.
Perfect analogy. And finally, the bottom tier, we've got low severity.
So that's what? Typos, stuff like that?
Yep. Cosmetic issues, minor inconsistencies, a typo in the help text, a button label that's not quite clear. They affect the polish, but not the core functionality.
Interesting. So it's not just, is this a bug or not? It's how bad is it, really?
You got it. And how those severity levels are decided, well, that's
Yeah.
where things get even more interesting.
How so?
Because it's not always clear cut.
Right. User reactions, you can't predict everything.
It's a mix of objective criteria, the technical impact, and the subjective stuff.
Mm.
How will users feel about this bug? How will it affect the brand?
So there's like a whole thought process, a decision tree happening behind the scenes.
Big time. Sometimes there are debates about what level to assign, and that's where the test manager's experience, their judgment calls, really come in.
Okay, fascinating stuff.
Mhm.
So we've discovered our defect, we've categorized it. What happens next in this bug squashing journey?
On to step 3, and that's where the developers really get to shine.
Ooh, we're about to see some action.
We're talking resolution, my friend. The bug, all neatly labeled, it's assigned to a developer, and they get to work.
So it goes from like a theoretical problem to an actual fix in progress.
You got it. Think of it as a relay race.
I love a good analogy.
Bugs passed off to the developer, they investigate, dive into the code, implement a fix.
Then the baton's passed again?
Yep. Fix is scheduled for release, gets bundled into the next software update, and then the testing team comes back in. Got to make sure that bug is gone and didn't cause any new problems.
A real team effort. Everyone's got their role to play.
I'll never forget. Worked on this project once. Tiny bug, just in a date field. Caused a massive billing error.
Oh, no.
Thousands of customers overcharged. Talk about a headache.
Mhm.
Shows you why this thorough testing and resolution process, it's not just a nice to have, it's crucial.
Absolutely. Even seemingly tiny bugs can have huge ripple effects. So the fix is in, the testing team is giving it the thumbs up. Where do we go from there?
Step 4, my friend, verification. Got to double check our work, make absolutely sure that bug is gone, and we didn't accidentally create new ones while fixing the old one.
Like checking your math homework twice before handing it in.
Exactly. Got to be thorough.
Makes sense. And then is that when we get to declare victory?
Almost. Step 5, closure. We get to check that bug off our
That'd
list.
be so satisfying.
Oh, it is. But even though it's closed, we don't forget about it. The whole process from discovery to closure, it's documented.
So it's like a bug's autobiography, from birth to demise.
Haha, I like that. But seriously, that documentation is gold. Helps us spot patterns, predict potential issues in the future, just constantly improve the process.
Right, makes sense. All right, last step then, right. Step 6, management reporting. We're getting into the data side of things now.
We are. Tracking metrics, things like defect density, how many bugs we're finding per lines of code, and this thing called defect leakage ratio, how many bugs slip through and make it to the final product.
Okay, defect density, I get that. More bugs per line of code probably means, more chances for problems. But what's so important about this leakage thing?
Think of it like this. No matter how good you are, some bugs are going to get past you. The leakage ratio tells you how effective your process is at catching those bugs before they hit your users.
Ah, so a high leakage ratio means your testing isn't cutting it.
Could be. You might need more testers, better tools, more time for testing. Got to figure out what's going wrong.
So it's a way to actually measure and improve the whole system, not just pat ourselves on the back for finding some bugs.
Exactly. And those improvements lead to better software for everyone. Think about a time you used an app, it was super buggy, frustrating,
Uh-huh.
then an update came out, and it was like night and day.
Happens all the time.
That, my friend, is effective defect management in action. And it's easy to take those improvements for granted, but there's a whole team behind them working hard to make it happen.
Okay, so we're getting a real sense of how this all works, the big picture. But before we go any further, I gotta bring up something that always trips people up.
I think I know where you're going with this.
GRU99 explains this so well. The difference between a bug and a defect.
It's subtle but important.
It is. Lay it on us. What's the distinction?
Simple terms. Bug is the error in the code itself. The defect is how that error shows up, how it behaves in the software.
Got any analogies for us? Always helps.
Typo in a recipe. That's a bug. Burnt cookies, that's the defect.
Oh, I love that. So the bug's the cause, the defect's the effect.
Bingo. And one bug can lead to multiple defects, right?
Yeah.
It's a domino effect. One small coding mistake can snowball into a whole bunch of problems for the user.
Okay, that makes a lot of sense. So when a tester finds a defect, what happens? They, send up a flare?
More like a detailed report, think of it as a detective's case file. The bug report. Got to have all the vital info. What's the problem? How do you reproduce it? How severe is it? All those clues to help track down and eliminate that bug.
So it's not enough to just go, hey, this thing's broken.
Nope. You got to give them the evidence, the steps to reproduce it, the whole 9 yards. A good bug report, that's crucial for actually getting stuff fixed.
All right, we're really building up our bug squashing toolkit here. So we've got clear communication, a well-structured bug report, a team working together. But earlier, we talked about defects coming from 2 places, the testing team and the stakeholders. Does it actually matter where a bug comes from? Like, does it change how it's handled?
Great question. And the answer is yes, it can. Defects found by testers, they often point to things like code errors, integration problems, performance bottlenecks, stuff you need a trained eye to see, someone who knows the software inside out.
So is like having a building inspector come in and find a crack in the foundation? You and I might not see it, but they know it's trouble.
Perfect analogy. Now, defects reported by stakeholders, those tend to be more about functionality, user experience. These are the people actually using the software in the real world. They might run into issues that nobody anticipated during testing.
Okay, so that's more like a homeowner noticing a leaky faucet. They might not know why it's leaking, but they know it's a problem.
Exactly. And those stakeholder-reported defects, those can be the trickiest to solve. Because it might be about how users are interacting with the software in ways the developers never even thought of.
So you need a system to gather that feedback, make sense of it.
Big time. That's where things like beta testing, user feedback forms, all that comes in. It gives you real-world insights that you just can't get from lab testing alone.
It's like crowdsourcing your debugging.
Exactly. But, and here's the catch, what a stakeholder sees as a defect might actually be a design choice or a feature they just don't understand.
It's like someone complaining that their car doesn't fly. Not a defect, it's just not something it was designed to do.
Exactly. So you need a process for evaluating that feedback. Is it a real defect? Is it a misunderstanding? Or maybe it's a great idea always. You got to bridge that gap between the technical world of the devs and the real-world experiences of the users. It's a two-way street.
Reading through this Guru 99 guide, it really struck me how much emphasis they put on that human side of things. It's not just about code, it's about people.
100%.
Yeah.
And speaking of the human element, I think we got to acknowledge, dealing with bugs, it can be emotionally tough. You pour your heart into building something, then someone comes along and points out all the flaws.
It's gotta sting a little. Nobody likes to be told they made a mistake.
And that's why having a positive team culture is so crucial. You need an environment where people can talk openly about bugs, share their struggles, help each other find solutions without fear of judgment or blame.
It's about celebrating the wins, too, right? Every bug fix, no matter how small, it's a step forward.
Absolutely. That sense of progress, it can be super motivating, especially when you're up against a really tough bug. Like solving a puzzle. Every piece you put in place gets you closer to the solution.
So it's not just managing the defects in the code, it's managing the impact of those defects on the people working on them.
That's a great way to put it. And that requires good leadership, creating a supportive environment.
Absolutely. So we've talked about the process, the people, but what about the bigger picture? How has defect management changed over time? I mean, software development has come a long way from punch cards and room-sized computers, right?
Oh, yeah. And defect management has evolved right alongside it. Think about it. Early on, testing was mostly manual, tracking bugs on paper or spreadsheets.
It's mind-blowing how much has changed. Now we've got automated tools that can run thousands of tests in minutes, catching stuff that would have taken humans forever to find.
And those tools, they've been a game changer. Made defect management faster, more efficient, way more thorough.
And we can't forget about collaborative platforms, bug tracking systems. Teams can work together from anywhere in the world now. Technology has really transformed this whole process. But with all that said, do you think the core principles of defect management have actually changed all that much?
That's a great question. At its heart, yeah, it's still about finding and fixing bugs.
Yeah.
But the how we do it, the tools, the techniques, that's evolved tremendously. It's like traveling by horse and buggy versus traveling by airplane. Destination's the same, but the journey is totally different.
I love that analogy, and I think it highlights something important. While the technology changes, the underlying principles of collaboration, communication, that commitment to quality, those are timeless.
Couldn't agree more. And those principles are what allow us to create software that's not just functional, but reliable, enjoyable to use. It's about creating something people actually want to use.
So we've talked about the process, the people, the history, but what about the pitfalls? Are there any common traps that teams should watch out for, things that can derail the whole bug squashing effort?
Oh, for sure. One of the biggest ones is inadequate testing. Sometimes, deadlines, budgets, whatever.
Yeah.
Teams try to cut corners on testing, figuring they'll catch those bugs later.
Ooh, that sounds risky.
It is. Like building a house on a shaky foundation.
Yeah.
You might get the walls up, but eventually the whole thing's going to crumble.
Makes sense. So thorough testing is essential. Can't skip that step. What else?
Poor communication between the testers and the developers.
Yeah.
That's a classic. If there's confusion about what's a bug, how to reproduce it, You end up with delays, frustration, the whole process breaks down.
It's like they're speaking different languages, right? One says widget malfunctioning, the other hears thingamajig needs tweaking, and nobody's on the same page.
Exactly. Clear, consistent communication is crucial. That means standardized bug reporting systems, clear channels for feedback, a real dialogue between teams.
Right, and we can't forget the human factor here either. Sometimes developers, they can be a little resistant to feedback, especially if they feel like their work's being criticized, right?
Totally understandable.
Hmm.
Nobody likes to be told they messed up, especially on something they put their heart and soul into. But a healthy defect management process, it recognizes that finding and fixing bugs, it's a team effort. It's not about blame, it's about making the product the best it can be.
So it's all about building that culture of respect, open communication, everyone working towards the same goal of quality.
Exactly. It's about seeing bugs not as failures, but as opportunities to improve.
Okay, love that. So before we wrap up this part of our deep dive, gotta ask you about the future. AI, machine learning, everyone's talking about it. How do you see these technologies impacting the world of bug squashing?
It's already happening, and it's only going to get bigger. We've got AI-powered code analysis tools now. They can scan code for potential problems as it's being written, almost like a spell checker for software.
So it's like having like a virtual pair programmer looking over your shoulder, giving you tips as you go.
That's a great way to put it. And they can spot things like security flaws, performance issues, even just inconsistencies in the code, all before they become major headaches.
That's incredible. Saves everyone a lot of time and stress, I'm sure.
Absolutely. It's all about shifting left, catching those issues early on when they're easier and cheaper to fix.
So instead of waiting for bugs to pop up during testing, you're trying to prevent them from being born in the first place.
Exactly. And AI is playing a huge role in making that happen.
That's amazing. Now, this deep dive has focused on the technical side of things, but I want to get your thoughts on something a bit bigger. How does defect management fit into the whole conversation about ethics, about responsibility in software development?
It's a crucial question. The software we create, it impacts people's lives in huge ways, so we have to build it with strong ethics in mind. And defect management is a key part of that.
In what way?
By making sure our software is reliable, safe, free of harmful defects.
Yeah.
That's how we uphold our responsibility to the people who use it.
So it's not just about making it work, it's about making sure it works well and doesn't put anyone at risk.
Exactly. Think about the software that runs our cars, our medical devices, financial systems. One tiny defect in those could be catastrophic.
Whoa, yeah, suddenly typos seem a lot less important.
Right. It's about building trust with users, protecting their data, making sure technology is used for good.
So defect management, it's actually at the heart of some really big questions we're facing as a society, especially as we rely more and more on technology.
Absolutely. And the software keeps getting more complex, more intertwined with our lives. So the ethical side of things is only going to become more important.
It's funny. As we've been talking, I keep thinking this whole idea of defect management, it's not just about software, is it? It's kind of about life in general. We all make mistakes. We all have flaws. It's how we deal with those imperfections that matters.
I love that connection. Whether it's a bug in our code or a flaw in our thinking, the key is to approach it with this mindset of continuous improvement.
See those imperfections not as failures, but as opportunities to learn and grow.
Exactly. Embrace the process, acknowledge the mistakes, keep striving to do better.
Well said. I think that's a fantastic place to wrap up this first part of our deep dive. We've explored the steps of defect management, talked about communication, looked at how the process has evolved over time, even got a glimpse into the future with AI.
And hopefully our listeners have a newfound appreciation for this hidden world of defect management and the folks who work so hard to make the software we rely on as good as it can be.
Absolutely. So next time you run into a bug, don't just get annoyed. Take a second to think about the whole process behind fixing it, all the work that goes into making our digital lives a little smoother.
It's a fascinating world, and we've only just scratched the surface.
That's a great point. There's always more to explore.
Always. And remember, every bug fix, no matter how small, it's a win for the developers and for the users.
Love that. A win-win. All right, until next time, keep exploring, keep learning, and keep those bugs at bay.
So a good bug report, it's like a roadmap to actually fixing the problem. But what makes a bug report truly effective? Like, are there certain ingredients that make it stand out from the crowd?
Oh, absolutely. First and foremost, clarity. Imagine you're a developer, right? And you get a bug report that just says, app crashes sometimes. Not very helpful, is it?
Nope, not at all. Like, where do you even begin with that?
Exactly. It's like trying to find a needle in a haystack, but you don't even know what the needle looks like.
Okay, so what should a good bug report include?
Well, first off, you need a clear, concise description of the defect, what's happening that shouldn't be, or what's not happening that should be, and use language that everyone can understand, right? Avoid all that technical jargon.
So it's not just about being technically accurate, it's got to be understandable to the whole team.
Exactly. And then, just like a good detective, you gotta provide evidence.
Ooh, I like where this is going.
That means including the specific steps to reproduce the bug. So instead of just saying, this button doesn't work, you'd actually walk them through exactly how you got to that broken button.
Precisely. Think of it like giving someone directions. You wouldn't just say, go to the store. You'd give them specific turns, landmarks, street names. A good bug report does the same thing, guides the developer right to the source of the problem.
Okay, that makes a lot of sense. And of course, we've already talked about severity levels, so that needs to be in there too, right?
Absolutely. Got to let the team know how urgent this bug is. But there's more. Visuals can be super helpful too.
Oh, right, like screenshots.
Yep. Screenshots, even screen recordings, to actually show the bug in action. Sometimes it's just easier to see the problem than to describe it.
A picture is worth 1,000 words. So we've got clear communication, a well-structured bug report, a team ready to squash those bugs. But, we talked earlier about defects coming from two main places, the testing team or from stakeholders. Does it actually matter where a bug comes from? Like, does it change how it's handled?
It's a great observation. And yeah, it can actually make a difference. Defects found by the testers, they often point to things like code errors, integration problems, performance bottlenecks, stuff you need a trained eye to spot, someone who really understands the inner workings of the software.
Okay, I'm with you so far.
It's like, imagine having a building inspector come in and find a crack in the foundation. You or I might not notice it, but they know it's a big deal.
Right, they know what to look for.
Exactly. Now, defects reported by stakeholders, those tend to be more about the functionality, the user experience. These are the people actually using the software out in the real world, and they might run into issues that nobody even thought of during testing.
Okay, so that's more like if I'm using my banking app and suddenly I can't transfer money, even though everything seems to be working fine on the back end.
Exactly. And those stakeholder-reported defects, those can sometimes be the trickiest to solve because it might involve how people are actually interacting with the software in ways that developers didn't anticipate.
So you really need a good system for gathering and making sense of that feedback, right?
Absolutely. That's where tools like beta testing, user feedback forms, all that comes into play. They give you those real-world insights that you just can't get from testing in a lab.
It's like you're crowdsourcing your debugging, tapping into the collective wisdom of your users.
Exactly. But, and here's the thing, what a stakeholder perceives as a defect might actually be a design choice or a feature they just don't understand yet.
It's like complaining that your car doesn't fly. It's not a defect, it's just not a feature.
Right. So you need a process for evaluating that feedback, figuring out, is this a real defect? Is it a misunderstanding? Or maybe it's even a great idea for a future feature.
So once again, communication is key. Everyone needs to be on the same page.
Always. It's about bridging that gap between the technical world and the real-world experiences of the people using the software.
It's interesting, reading through this Guru 99 guide, it really struck me how much emphasis they put on that human element of defect management. It's not just about the code, it's about the people.
100%.
Yeah.
Speaking of the human element, I think it's important to acknowledge, dealing with bugs, it can be tough emotionally. You pour your heart and soul into building something, and then someone comes along and points out all these flaws.
Yeah, that's got to be hard.
It is. And that's why a positive team culture is so important. You need an environment where people can talk openly about bugs, share their struggles, help each other find solutions without feeling judged or blamed.
It's about celebrating the small victories, too. Every bug fix, no matter how tiny, it's a step in the right direction.
Absolutely.
Yeah.
That sense of progress can be super motivating, especially when you're dealing with a really nasty bug. It's like solving a puzzle, Every piece you get into place brings you closer to the solution.
So it's not just about managing the defects in the code, it's about managing the impact those defects had on the people who are working to fix them.
Couldn't have said it better myself. And that takes good leadership, creating a supportive and collaborative environment.
So we've talked about the process, we've talked about the people, but what about the big picture? How has defect management changed over time? I mean, software development's come a long way since punch cards and room-sized computers, right?
Oh, yeah. Defect management has evolved right alongside it. Think about it. In the early days, testing was largely manual, you know, tracking bugs on paper, in
Can't
spreadsheets.
even imagine. And now we've got these automated tools that can run thousands of tests in minutes, catching stuff that would have taken humans forever to find.
Right, those tools have been a game changer. They've made defect management so much faster, more efficient, and way more comprehensive.
And we've got collaborative platforms, bug tracking systems. I mean, teams can work from anywhere in the world now. Technology has really transformed this whole process.
It really has.
But with all that said, do you think the core principles of defect management, have they actually changed all that much?
Hmm, that's a really interesting question. At its heart, I think defect management is still about finding and fixing bugs. But the how we do it, the tools, the techniques, that's all evolved tremendously. It's like, traveling by horse and buggy versus traveling by airplane. The destination is the same, but the journey is completely different.
Oh, I love that analogy. And I think it highlights something important. While the technology might change, the underlying principles, collaboration, communication, that commitment to quality, those never go out of style.
Couldn't agree more. And those principles, they're what allow us to create software that's not just functional, but reliable, user-friendly.
Mm.
Something people actually enjoy using.
Okay, so we've covered the process, the people, the history, but what about the pitfalls? Are there any common traps that teams should be aware of? Things that can kind of derail the whole bug squashing effort?
Oh, for sure. One of the biggest ones is inadequate testing. Sometimes, with like tight deadlines, budget constraints, whatever, teams try to cut corners on testing, figuring they'll catch those bugs later.
Ooh, that sounds dangerous.
It is. It's like building a house on a shaky foundation. You might get the walls up, but eventually the whole thing's going to crumble.
Yikes. Okay, so thorough testing, that's non-negotiable. What else?
Another common one is poor communication between the testing team and the development team. If there's confusion about what constitutes a defect or how to reproduce it, you end up with delays, frustration.
Mm-hmm.
The whole process just breaks down.
Right. It's like they're speaking different languages. One saying the widget is malfunctioning, and the other one hears the thingamajig needs tweaking.
Exactly. You end up with a lot of wasted time and effort. Clear, consistent communication is essential. That means standardized bug reporting systems, clear channels for feedback, and a real dialogue between the teams.
Makes sense. And then, of course, there's the human element. Sometimes developers can be a bit resistant to feedback, especially if they feel like their work's being criticized?
Oh, absolutely. Nobody likes to be told they messed up, especially on something they poured their heart into. But a healthy defect management process, it recognizes that finding and fixing bugs, it's a team effort. It's not about blame. It's about working together to make the product the best it can be.
It's about creating that culture of mutual respect, open communication, everyone working towards that shared goal of quality.
Exactly. It's about seeing bugs not as failures, but as opportunities for improvement.
Okay, I love that perspective. So before we wrap up this part of our deep dive, I've got to ask you about the future. Artificial intelligence, machine learning, everybody's talking about it. How do you see these technologies impacting the world of bug squashing?
Oh, it's already happening, and it's only going to get bigger. We're already seeing AI-powered code analysis tools that can scan code for potential problems as it's being written, almost like a spell checker, but for software.
Whoa, so it's like having a virtual pair programmer looking over your shoulder, giving you tips as you code.
That's a great way to put it. These tools can help identify things like security flaws, performance issues, even inconsistencies in the code, all before they become major headaches.
Wow, that sounds amazing. Talk about saving time and stress.
Right. It's all about shifting left, catching those issues early on when they're easier and cheaper to fix.
So instead of waiting for bugs to pop up during testing, you're trying to prevent them from being born in the first place.
Exactly. And AI is playing a huge role in making that shift possible.
That's so cool. Now, our deep dive today has focused a lot on the technical aspects of defect management. But I'm curious to hear your thoughts on something a bit bigger. How does defect management fit into the whole conversation about ethics and responsibility in software development?
That's a really important question. The software we create has a profound impact on people's lives, and it's crucial that we build it with a strong ethical framework. Defect management is a key part of that.
How so?
By striving to create software that is reliable, secure, free of harmful defects, that's how we uphold our responsibility to the people who use it.
So it's not just about making software that works, it's about making sure it works well and doesn't put anyone at risk.
Exactly. Think about the software that controls our cars, our medical devices, our financial systems. A single defect in those systems could have devastating consequences.
Wow, yeah, when you put it like that, it really puts things in perspective.
Right. It's about building trust with users, protecting their data, making sure technology is used for good.
So defect management is actually at the heart of some really big questions we're grappling with as a society, especially as we become more and more reliant on technology.
Absolutely. And as the software we create becomes even more complex, even more intertwined with our lives, the ethical implications, they're only going to become more significant.
You know, as we've been talking, I keep thinking this whole idea of defect management, it's not just about software, is it? It's kind of about life in general. We all make mistakes, we all have flaws. It's how we deal with those imperfections that matters.
I love that connection. Whether it's a bug in our code, a flaw in our thinking, a mistake in our actions, the key is to approach those imperfections with a mindset of continuous improvement.
To see those imperfections not as failures, but as opportunities to learn, to grow, to do better next time.
Exactly. It's about embracing the iterative process, acknowledging our mistakes, and always striving to do better.
Well, I think that's a fantastic note to end on. We've explored the ins and outs of defect management, from the technical details to the bigger picture of ethics and responsibility. We've learned how bugs are discovered, categorized, and squashed, and how AI is transforming this whole process in some really exciting ways.
And I hope our listeners have gained a new appreciation for this hidden world of defect management and the people who work so hard to make sure the software we rely on is as good as it can be.
Absolutely. So next time you encounter a bug, don't just get frustrated. Take a moment to consider the whole process behind fixing it and the dedicated teams who are working to make our digital lives a little bit smoother.
Remember, every bug fix, no matter how small, it's a victory for the developers and for the users.
A win-win. I love it. All right, until next time, fellow deep divers, keep exploring, keep learning, and keep those bugs at bay. We talked about how AI can help, spot bugs, but what about this? AI actually helping prevent bugs in the first place. Is that science fiction or is that something you could see happening?
It's already starting. We've got these AI-powered code analysis tools now. They can actually scan code for potential problems as it's being written.
Whoa, really?
Yeah. It's almost like having a spell checker, but for code.
So it's like having like a virtual coding buddy looking over your shoulder going, hey, you might want to rethink that line.
That's a great way to put it. They can flag things like security vulnerabilities, performance bottlenecks, even just stylistic inconsistencies, and it catches it early before it becomes a big problem.
That's incredible. So you're not just like reacting to bugs, you're trying to stop them before they even exist.
Exactly. It's all about what we call shifting left in the development process. Find those issues early, they're way easier to fix.
Makes sense. Saves everyone a ton of headaches down the line. This whole deep dive, we've been focused on the technical stuff, the nuts and bolts of defect management.
Right.
But I want to get your take on something a little bigger picture. How does defect management fit into this whole conversation we're having about ethics and responsibility in software development?
Ooh, that's a good one. I mean, the software we create, it impacts people's lives in a huge way, so we have to build it with a strong ethical framework.
Absolutely.
And defect management, it's a crucial part of that.
How so?
Because by working to create software that's reliable, secure, free of harmful defects, that's how we're showing respect for the people who use it. That's responsibility.
So it's not just about making it work, it's about making sure it works well, that it doesn't put anyone at risk.
You got it. Think about the software in our cars, medical devices, financial systems, even just like social media platforms. The potential for harm if something goes wrong. It's huge.
Yeah, that's a sobering thought. The stakes are pretty high.
They are. It's about building trust, protecting data, making sure this technology we're creating is used for good, not for harm.
So really, defect management, it's at the heart of a lot of these big questions we're wrestling with as a society about how we want to live with technology.
I think so, yeah. And it's only going to get more important as software becomes even more complex and intertwined with our lives.
As we've been talking, I keep coming back to this idea that this whole concept of defect management, it's not just about software, is it? It's kind of about life in general. We all make mistakes. We all have, those little bugs in our system.
I love that.
It's how we deal with those imperfections that really matters.
Yeah. Whether it's a bug in our code or a flaw in our thinking or just a mistake we made, The key is to approach it with a mindset of, like, okay, how can I learn from this? How can I improve?
Not seeing it as a failure, but as an opportunity to get better, to iterate.
Exactly.
Well, on that note, I think we've covered a ton of ground today. We've gone deep on defect management, from the nitty-gritty details to the bigger picture, the ethics, the future of it all.
Hopefully our listeners have a new appreciation for this whole world,
Mhm.
the people behind the scenes working hard to make the software we rely on as good as it can be.
For sure. So the next time you run into a bug, don't just hit that report button and move on. Take a second, think about that whole process we talked about, the people behind it, all working to make our digital lives just a little bit better.
Every bug fix, no matter how small, it's a step forward.
I like that. All right, folks, that's our deep dive for today. Until next time, keep exploring, keep learning, and keep those bugs at bay.